Okay, here we are. This is the most common AP free response question that is asked. So yesterday we did probably the second most common AP response question was asked, which was area and volume. So we go to something that you were familiar with. We go to particles of motion. It says a calculator may be required. A calculator is required. Particle moves along the x-axis with the velocity given by that thing from 0 to 8. Particles at position x equals 3 at time equals 0. Determine the velocity of the particle at time equals 3. Anybody? Tell me what to do. Yeah, simply just plug in 3, right? So I'm going to take out my calculator. I'm going to go into y equals. I'm going to clear this stuff out. I'm going to go sine of x minus pi. And I'm going to divide that by x. And it says just find the velocity of the particle at time equals 3. So I'm going to do v of 3. So I go ahead and I can go to my table. I want to make sure I'm working in radians. I happen to be in degrees because I teach a different class. And I type in 3, and there we go. We got negative 0.047. And there is no label in this situation. Good. Now I want to know the acceleration of the particle. You know how to do this. Excellent idea. Unfortunately incorrect. Derivative. Yep. V prime of 3 is equal to a of 3. So acceleration is the derivative of velocity. You have to know that on the test. So how do I calculate the derivative at time equals 3? So I can calculate number 6. And I type in 3, and I get 0.345. That's the acceleration. Is the particle slowing down or speeding up at time equals 3? Slowing down. Because a of 3 and v of 3 are different signs. Yes? No? Notice how it says justify your answer. If you don't justify your answer, you won't get the point. They want you to write this. What we're doing is exactly what they're looking for. When does the particle change direction? Tell me something about the velocity function when the particle changes direction. That's the beautiful thing about velocity. It has both direction, right? Yeah, when it crosses the x-axis. So what Colin is saying is that we want to consider when v of t changes sign. Because if the velocity is negative, that means the particle is traveling to the left. And if it's positive, it's traveling to the right. So we have right here in front of us a velocity function. So I'm going to go into my window and I'm just going to change the y values to negative 1 and positive 1. I happen to know that those are the largest and smallest values of this function. And as I look at the graph, I'm looking over the course of this time from 0 to 8 where it changes sign. So I'll move my cursor. Looks like it changes sign about there. Everybody agreed? and it looks like it changes sign about there. Agreed? And it goes all the way till time what? And so it looks like it changes sign how many twice? Twice. Changes sign twice. So so V of t changes from negative to positive at time equals, and how do I find that spot? Good try. Incorrect. Excellent try. Incorrect. 0. You want to find the 0 of the function?
You hit 0?
Yep. Yep. Don't worry, guys. This was so this is COVID. This is COVID right here. So there was a 3-day deal where last year we took you through some calculator operations. You weren't here. We skipped it. I was able to do it this year with the group. So you would have known that had we had a normal year last year. So 0. That's how we find where across the x-axis is we're finding the 0 of the function. So you go to the 0 spot. It asks for the left bound. And so I move to the left of my 0. Am I above or below the x-axis at that time? Below. So I'm going to press enter, and now I move to the right. And as you move to the right, you have to make sure you cross over the x-axis. So Bijak, tell me when I've crossed over. Have I crossed over? Yep, thank you. So anywhere that you've crossed over, you just press enter on guess. You get x is 3.141, which is the same as pi. We'll just write 3.141. And that isn't the only time that velocity changes sign. It also changes sign where? Over that spot. Okay. So I press second calculate. I choose the 0. I go over to my 0. And what's my calculator asking me to do? Left bound. So move to the left. Are you above or below? You're above. So press enter and then move to the right until you drop below. I'm below. Press enter and it will find that spot perfectly for you. Comes out to be 6.28, which is 2 pi, but we'll just write 6.283. And V of t changes from positive to negative at time equals 6.283. And that will be a very good answer for that question. So you have to understand the velocity tells us the direction of travel, up or down or right or left, and you need to interpret that with the graph. Find the position of the particle at time equals 5. Who remembers how we determine position? Start plus displacement. Good. So therefore, what is my starting point? It says that I have a position of 3 at time equals 0. That's my starting point, which is at 3. And I add that to what? How do you determine displacement? Integral from 0 to 5, because we're looking at time as 5 of v of t dt. If you remember that, you're going to get a point for that. Go to our calculator. So I can calculate what? Yeah. Now we do 7. And our lower limit is 0, and our upper limit is 5. It is pretty cool your calculator can do that, isn't it? I mean, it's kind of neat. Negative 1.5499. So 3 plus negative 1.5499. And we will calculate that. Three minus 1.5499, and I get 1.4501. So that's my position. It didn't. And sometimes they won't. Question.
I don't get, like, usually don't we get, like, the equation of displacement? Like, don't we get the position of your velocity, so like, how does that, like, change it? I don't understand.
Okay. So I believe I'm going to do my best to answer Jenna's question. And so there were times in class that I gave you, say, s of t is equal to some function, say t squared minus 4t, and then you took the derivative and you took the second derivative to come up with acceleration. I would say that as I've looked at AP exams, I would say that 20% of the time they give you position. I would say 70% of times they give you velocity, and I would say 10% of time they give you acceleration. And so we're going to default to saying that we're going to study the velocity ones for the most part. That's predominantly what they are going to give you. Does that answer your question?
No. I'm good. I'll ask after.
Sounds good. All right, so let's check out the next piece. Find the total distance. How do we determine distance traveled? This is not displacement, this is distance. Thank you. Absolute value of what? Integral 1 to 6 of the absolute value of v of t dt. So you should remember this from your chapter 5 test. You guys were pretty good at this. I go into my y equals, and whoop, I just deleted that, my bad. So I'll go to my catalog, absolute value, and I've got sine of x minus pi. I divide that by x. I got to close my parenthesis for the absolute value, I believe. And if I look at the graph should definitely be, got to go to, I made an error here. It looks like I've got an extra parenthesis on that. 1, 2, I'm just closing the, okay, I've got this one right here. Got it. So I'm going to look at the graph, and if I've done it correctly, it should stay above the x-axis the entire time. If it didn't, then I know I made a mistake, but it does. That's kind of cool. And I'm going to second calculate. I'm going to do number 7. And I'm going to roll from 1 to 6. And I get 1.333. All right. Please spend 1 minute and talk to your peers and see if you can determine the difference between question G and H. That's what gets people. Ready, set, go. To that. So average velocity, notice this is the key. True or false? I'm given the velocity function. True. So therefore, your formula for finding the average value of a function is going to be 1 over b minus a, or 1/8, integral 0 to 8 of v of t dt. Did you get that? So in this situation, I grab my calculator. I go back to y equals. I get rid of the absolute value piece I had there. And I calculate number 7. I go from 0 to 8. And then I multiply by 1/8. Whoop, that wasn't right. Somebody got a result here. What'd you get? Negative. Divided by 8. So it looks like that's probably pi over 2, huh? Maybe not. Negative 1.574 divided by 8. And I get negative 0.19675. That's the average value of the function. And then find the average acceleration. Thoughts? Excellent. Yeah, this is going to be your slope function. So this is a slope function because that's the rate of change. So I got v of 8 minus v of 0 divided by 8 minus 0. So if I go to my calculator and I type in 8, I get negative 0.1237. If I type in 0, I get an error, huh? That's too bad. So it looks like I wrote a bogus problem. I didn't even realize that. Does it look like it's -1? Yeah, so it looks like the limit must be -1. Obviously, it's undefined because if you look at y equals, you can tell you're dividing by 0, right? But we'll just, we'll just say, we'll just pretend it's like -1. So I won't give you a problem like that, promise. And then, we got -0.1237. We're going to add 1 to that, and then I'm going to divide by 8. And even though it's undefined at that spot, this is still an answer that gives appropriate meaning. If you were going to look at the slope from here to here, it's 0.1095. Good. All right, cool. Flip it over. Let's do one more. What's different about the problem right here compared to the problem we just did? There's no calculator. Yep.
So what do they tell you? Like, how do they stop you from using your calculator?
There's a proctor in there, and the proctor will say, so just to be clear, so you asked a really good question. You got 28, you got 17, you got 2, and then you got 4. So this is multiple choice. You got, you got free response. You got free response. Yep. And then you got multiple choice. You got multiple choice. So this is going to, again, be no calculator, and then calculator, calculator, and no calculator. So what they'll do is you won't have one at the beginning, and then they'll allow you to have it for this stretch. And then before you move on, they'll say, please put away your calculator before anybody moves on.
That would make sense. So, like,
Good.
I thought it was just going to be like random questions.
Yep.
Like, no calculator.
Any other questions about that? Any other concerns? No, don't be scared. Just, it's okay. It's okay. Here we go. All right. Let's try this out. Okay, rain's coming down. We got a system moving through. Hopefully after the system, then we'll see. If we check out the weather right now, we've got, you can see it's this system right here that's just pushing through. After that, hopefully we'll be able to see what more is headed along the way, and maybe they can make a better decision about what we're actually going to be encountering. So who knows? We'll see. Let's finish this, and we'll look back at the weather. Here we go. Determine when the particle changes direction. We have the function b of t is equal to this. From 0 to 12, particles position x equals -2, time equals 0. So you tell me, where would you even begin? And this is more like what the AP exam is going to be. You're going to come across a question, and you'll be like, shoot, I don't even know what to do. It's the same type of questions. It's just now you don't get a calculator. Determine when the particle changes direction. What would you be looking for if you had your calculator? Where it switches sign on the graph. So we need to make a graph of that. Fortunately, you guys know how to make a graph. As you start making graphs this back in 10th grade. What does a graph look like? Yeah, what's the y-intercept? Yeah, see, it's no big deal. So we got -6 here, and it, goes like that, right? So we just want to find where it crosses the x-axis. Agreed? So I want to find where this thing crosses the x-axis. So yeah, set it equal to 0. 2 roots of x minus 6 is equal to 0. And that'll be the difference. Those of you who can think on your toes, and those, maybe you can't. So it's just the way it is. Okay, I add the 6, I divide by 2, root of x is equal to 3. Square both sides, you get x is 9. So it looks like, we drew a graph, determine when the particle changes direction. We say b of t changes from what to what? From negative to positive at time equals 9. Determine the total distance the particle travels for time 0 to 9. How do we determine total distance? The absolute value. So the integral from what to what? 0 to 9 of Absolute value of v of t dt. Now, what do you notice about the graph of the velocity function from 0 to 9? It's all negative. So we're going to come out with a negative result. We just make it positive then. Agreed? So in order to figure this out, we have to do the integral of 2x to the 1/2 minus 6 dx. Well, that's no big deal. We've spent our whole last 2 months doing that, right? What's the antiderivative of 2x to the 1/2? 2x to the 3/2 divided by 3/2 or multiplied by 2/3. So you're going to get 4/3 minus 6x. And we're going to evaluate that where? 9 and 0. Okay. So we don't have a calculator. What is 9 to the 3/2? 27 square root. No, 9. No, blah, blah, blah. Stop it. What's the square root of 9? Cubed? 27. Divide by 3? Times 4? So we get 36 minus 54. What's 36 minus 54? Negative 18. So negative 18. So what is the total distance traveled? 18 units. Okay, and we take the absolute value, get 18. So that's the total distance that is traveled. Obviously, we know it's headed off to the left direction because the velocity function was below the x-axis. Okay? Now, it says find the position of the particle at time is equal to 4. Okay? No big deal. We can do this. We've got this set up right here. I'm just going to change that from 9. I'm going to change it to 4. And then how do we determine position again? What do you remember? Start plus displacement. Well, what's the start? -2. And so we're going to add to that the displacement. It's not the absolute value, it's the displacement. It's from 0 to 4 of v of t dt. Now we have the 4 up there, so we can calculate that. Can somebody remind me, how do I calculate 4 to the 3/2? What do you do? How do you do 4? Yeah, so that you cube it or you take the square root. Either one, it's up to you. So I'm going to take 4, I'm going to square root it to get 2 to the 3rd. 8 times 3 times 4. 32, divide by 3, so I got 32/3. Yep. If you take 4 and you dump it in here, you have to take 4 to the 3/2 power. The 3 means you cube it. The 2 in the denominator means you take the square root. The denominator is the root. The top one is the power. Got my point? So it's 4 to the 3rd, which is 64. Square root is 8. Or 4 square root is 2. Cubed is 8. Either way, you come up with 8. Times 4 is 32 over 3. Minus what? 24? Because 6 times 4 is 24. Looks like we need a common denominator here. Anybody? 24 times 3? Good. So 32 over 3 minus 72 over 3. What's 32 over 3 minus 72 over 3? Negative 40 over 3. So the current position is going to be -2 plus negative 40 over 3. Common denominator? Yeah, so -6 over 3, right? So we get negative 46 over 3. That's its current location. You can tell it's a little bit different when you don't get your calculator, right? I bet you're looking forward to the time where you get your calculator, aren't you? All right, find the average velocity of the particle from time equals 0 to time equals 9. How do I determine the average velocity if I'm given the velocity function? Good. 1 over 9 times the integral 0 to 9 of v of t dt, which is 1 over 9 times. Did we calculate the integral from 0 to 9 of v of t dt? What did we get? We got negative 18, didn't we? Is when we took the absolute value. You can see how it's easy to make small mistakes here, right? You could easily grab 18. We want to use negative 18 times negative 18. So what is 1/9 times negative 18? Negative 2. So that's the average velocity. How do I determine average acceleration? Slope. So v of 4 minus v of 1 divided by 4 minus 1. Good. You guys are really doing well. You really are. Okay. Trust me, in other years I've had to stop and chew people out by now. So you guys are doing a great job. All right. So what if I plug in 4 to this? What do I get? Negative 2. You guys can't see me chewing somebody out, can you?
Oh, I thought you said shoot.
Oh, shoot. Oh no, I don't. All right. Okay, so now I plug in 1, and what do you get if you plug in 1 for that guy? I got negative 4. So negative 2 plus 4, I get 2 over 3. That's the average acceleration. Uh-oh. Now it says find the acceleration particle at time equals 4. How do I find acceleration? Derivative. You guys remember how to take the derivative of that guy? Okay. All right. So I got 2 roots of x minus 6. Derivative. What is the derivative of 2 roots of x? That's 2x to the 1/2.
1 over 2 root of x.
So 1 over just the root of x then?
Oh, crap. Yeah.
And then the derivative of 6 is 0. And then I want to find the acceleration at time equals 4, so I plug in, and you get, yeah, so the acceleration at time 4 is equal to the derivative of the velocity at time 4, which we figured out is in fact just 1/2. So the acceleration is positive, okay? It says that the particle speeding up or slowing down at time equals 4. Well, in order to figure out if it's speeding up or slowing down, we have acceleration at time 4 is acceleration at time 4 is equal to 1/2. What am I missing in order to determine that answer? I need just the velocity at time 4. How would I figure out the velocity at time 4? Yeah, just plug 4 in. And if you look at that function up there, if you plug 4 into here, what do you get? You get negative 2, don't you? So it looks like we have the acceleration at time 4 is 1/2. The velocity is negative 2. So is the particle speeding up or slowing down? Particle is slowing down. Because V of 4 and A of 4 are different signs. Now, we've seen our fair share of area and volume and motion problems now, haven't we? Is it fair to say that some of them can still be challenging? Is it fair to say that you should not encounter them and say, I have no idea what's going on? So when you get to your AP exam and all of a sudden you've got 2 free response and one of them you don't recognize and the other one is a motion problem, you jump right to that motion problem, don't you? Because folks, when I say 15 minutes per problem, that means 30 minutes to do 2. So you could spend 20 and 2 if you want, or 20 and 10. Get my point? And then when you open up, you get 4 free response and no calculator. You look through those right away. And you say, out of these 4, which ones do I have the best chance at? Oh, yay, they got a volume problem. They got a slope field problem. I know how to do those. Mr. Gens taught me how to do those. These other 2 problems, I have no idea. Oh, no, is he going to judge me? No, he's not. Like, I get it, folks. I'll end with this story. I get where you're at. I'm so happy that you guys are trying.